the data to the brain, and the brain start understanding what you have looked into. So something similar to that, like one portion is removed, what is that? Sensor organs. But what is captured, that information, is the data which is fed to the brain. So something like it will be fed to the machine, and machine start learning from that actually. If machine start learning from that data, then we call it the machine learning. So if you're not able to understand, let me go to the things. So how exactly we used to do the traditional programming? So we used to give a input and output. Like for example, if you are trying to find out a prime number between 1 to 10, then what you are trying to do is actually, like I am trying to give the input. What is the input? Some numbers 1 to 10, and then what is the expected output is identifying whether the prime number or not number. And then who will be doing the writing the program? We will be writing the logic, identifying each number, whether the number given to the machine is prime or not. We will be writing the logic. Means like what we will be doing, we will be giving the input to we know what is the input and what is the output, but we will write the logic for doing that activity. Not the machine does that logic to do that activity. Means like identifying whether the number is prime or not is everything is your logic. You are not asking machine to do, because that the way we see, we don't say that like actually, like we won't teach actually like human beings that like, okay, this is a cup or this. It's like he observes and learns actually how it's communicating. But in this case, in traditional programming, we write the logic, what to do, what not to do, and something like that. So that is how it is a traditional programming. In the machine learning, we never write a logic. What we will do actually, we'll say this is the data. So you will take this data, and this is the input and this is the output, and you come up your own logic. So you come up your own logic. So something like something similar to this actually. Like so, for example, without machine learning and with machine learning is actually, I will be telling step by step what you are doing. In machine without machine learning, like first step by step, read the input and then find out the number. If number is not divisible by any other number from one itself and other than one, then it is called prime number. Means like we write all these logics and machine just executes this logic and then gives the result. But in the machine learning, we just give the feedback. So one is non-prime, 2 is prime, 3 is prime, and 5 is prime, 4 is not prime. So we just give what is the input, what is the output, and ask machine, you only figure out actually why I am calling one number as prime, one number is non-prime. So I'm not saying that like how to calculate whether the number is prime or not. What I am trying to give is actually, these are the prime numbers, these are the non-prime numbers, and this is the data, and you take this data, this is input, this is output, and you figure it out actually why I'm calling certain number as prime or not. So it's like logic is, or the program is designed by the machine. So machine based on the data, not based on the experience, but based on the data, it is learning. So that is the reason we call it as a machine learning. So something similar, if I have to elaborate further, so take in this example actually. So see, see what he is saying actually, like the person is saying that like automatically learn from the experience. Can you learn? So what he says actually, I can learn from the past data. So with the machine learning algorithms, means like if you give the past data, any information like past data, like you give the input and output, so automatically machine will try to figure out actually what is the logic behind that, and it learns from that actually. Then that is the reason we call as a machine learning. So how exactly it works actually? So for example, if I have to tell the similar case of prime number, go here. So how exactly it works? So if I am trying to teach the machine on the prime number, so if I will say that like what is the input and what is the output actually, and I have to see, for example, if one is not a prime number, if it is 2 is a prime number, so if it is 3, so prime number, so if it is 4, so not a prime number, so if it is 5 is a prime number, if it is 6 it is not a prime number. So I am trying to give this input and output. Means like what is this output is called? This is called label. This is also called as a label. So I am trying to prepare a data set with which has the input and which has corresponding output. So output, and I am trying to give to this to machine, and I'm the way if it is shown here. So this is called label data. What is called for label data is which has input and output is labeled. Means like label means like prime or non-prime, the classification kind of things. So So we have labeled data. I am trying to feed to the machine, and machine, what it does actually, machine learns from the data. So machine learns from that. Okay, it will try to figure out actually why one number is called prime number, why a certain number are called non-prime number. Next, what I will be doing now. So when the model is understood, means like machine understand that logic and figure out the equation to calculate whether it is prime or not. Then what we will be doing, I will be giving the new data. So for example, I have given the data from 1 to 10. So then I will try to figure out actually if I'm giving 11. So whether it is able to predict whether it is a prime or not. So if it is saying that like it is a not prime, then it has not learned well. So if it says actually it is a prime, then it has learned, because I have not given this information while training the model. It's like I have not given that information. So automatically it has figured out, and I have not written any logic to identify whether number is prime or not. What I have given is actually label data. What is the label data? Input and output information I have given to the machine, and machine is trying to figure out the equation, and it learned from the data and trying to figure out actually. So why this is most important? Why this is important? Let me discuss with one example. So how this is more perfect, or why it is so much useful in our real world. So take a case of house price prediction. So how should I do predict the house price? Based on the flat size of the house size. So one way is actually like this side is the size of the house and this side is the price of the house. So what I will be doing, so some examples, like for example, I will be saying that like whatever like house price, so per square feet rate, maybe I will be calculating. So I will be saying that like this is the size of the house, this is the size of the house. I will be figuring out actually per square feet rate. Actually means like rate is 2000. So then the price will be something like that. Into multiply that will be the price. So what is that actually? So what I am trying to figure it is actually y. So y I am trying to figure out, which is based on the x. So based on the x is the input, and there is some multiplication factor and there is some kind of a constant factor. What is this actually? This is a line equation. So why I'm trying to find out a line equation, and by giving the input x value is the square feet of the area, and y is the price. So how I'm trying to ask machine to learn? So I know that like for this square feet area, this is the area size of the price of the flat. So I'm giving this price and giving the square feet, and I'm asking the machine to figure out this m value and figure out this c value. But traditionally, if I'm not using machine learning, what I will be doing, I will be writing logic for calculating this equation. Means like how to find out a housing price, then I will be finding out actually taking the size of the house, and then I'm trying to calculate using some equations. Like I will be calculating m value and calculating c values, and then I'm trying to fit this equation. So what happens actually when I fit this equation? So for example, if I fit this equation, so price, housing price dependent something that like if I have calculated for this square feet, like so something that like this is 1000 square feet, here 2000 square feet, here something that 3005 square feet. So we know this price actually. What is the price for this actually? This is input we already know, and based on that I have written an equation. But if I have to find out a price for 2500, how I will be calculating new? So since this equation is known, so I will be putting this x value, then I will be calculating y value. This is pretty easy to program. But what happens other than the square feet, if I have another parameter? So another parameter is actually not type of the house, whether it is a villa or whether it is a flat or whether it is a independent house. So then how the price will be? Then what equation will become? Y is equal to some number x1 and some number x2 plus c. So now what is x2? X2 is the type of the house, x1 is the square feet of that. Then I have to calculate this equation, how what values of m and x, and what about it has more features. Like for example, if it has not only the one feature, it has something like floor price, room size, lot size, apartment, row house, corner house, location near to IT center, not, it's like so many features. Then what happens actually? It will become very tedious for us to calculate equations. Like how should I calculate? Y is equal to then so many m, so many x. So each one feature means one and x actually. So the equation becomes more and more complex, and writing logic for that becomes more and more complex. So that is the reason what happens actually. Without machine learning, we are not able to solve the complex problems, which has so many features, so many relationships between one features to the output and all those things. So it is very, very difficult to calculate those values and find out the equation, and so that like we can write a logic for that problem. But because of the machine learning, what happens actually, if I initially if I give the square feet and the price, so I will be calculating the square feet and the price. So I will give this data and train the machine model, and model will be built, and I will be predicting output. If assume that like if I add another thing, what I will be doing, another thing is actually type of the house. So again I will be feeding the data, different data. Automatically machine will figure out what is the equation, and then model will be ready for predicting the value. If I add one more data, again I will be creating the data set and training. Look, so even if it has 20, it is a 30, it is a 40, it is a 1,000 features, it doesn't take much time for me to train the model. Only thing it takes more is actually more computation time. Machine has to run for needs more computation to execute, understand from this pad. But like it will be much more easier for me to train the model, and it is the responsibility of the machine to figure out the equation and build a model. And what I will be doing next time, I will be giving the values and it will be able to predict me. So that is the reason. That is the reason machine is called machine learning. So I'm not coding anything. It is dynamic. Anytime if anything got changed, I'm just refeeding the things and it's getting learned. So what is the stages are there in the machine learning? If you see, two stages are there. So historical data you should be collecting, and you should be selecting the what is called algorithms you wanted to use, and then asking to model to get trained on those data. So that is called predictive model is built. So when the predictive model is built, what I will be giving, so okay, new data will be there. So I'm just feeding to the model, and model is giving the output. Irrespective of like, so if there is a change in the data, change in the pattern, it is not my responsibility. It is a machine responsibility. Machine will figure out, machine will be told. So since machine is started understanding the data and figuring out the equations and learning from the data, we are calling the machine is machine learning. So we are not calling that is a machine, traditional machine or robot, but we are calling this is a machine learning. Anybody has any question here who doesn't understand why we are calling this machine as machine learning? Okay. So, okay, next, is this the only one thing what machine learning does? Only the predicting the housing price or predicting some kind of value, stock price, or all the things? Is this the only one thing machine does? No, it does a lot of things actually. So this is, if you see, this is the another kind of application. What it does actually, if I'm giving the handwritten digit, so I'm asking machine to figure out actually whether it is a 2 or 3 or 4 or something that like. So means like I'm not writing the code to figure out. What I'm trying to do is actually I'm trying to give the digit and asking the machine to predict what is that actually. So this kind of things actually, what is actually, so this is not the prediction, this is saying that like identifying, so whether it is a 2, 3, 4, 5. So how many digits, different digits are there? So 10 digits are there. So means like we are saying that like this is kind of a classification. Why it is called, we are calling this as a classification? It will say whether this belongs to one class. What is the difference between the prediction and classification? Is prediction is a continuous variable values, classification is a discrete. So 0 is completely different than 1, 1 is completely different because they are different digits actually. So it can also identify classifications like, so one digit, what is the digit, or what is the alphabet. Alphabet is also like ABC, identifying it is alphabets. It's the also classification. Whether it is a COVID or non-COVID, there is also classification. Whether it is a color of a shirt, also is a classification. So, but what are the predictions? Housing price prediction, sales prediction, market, all those are predictions. So machine does prediction kind of models. Machine build a classification kind of model. Not only these two, actually machine also have multiple other types. Like if you see this diagram, so it has lot more things. So classification, for example, is actually diagnostic. Diagnostic means like identifying based on the X-ray image whether this person has a COVID or non-COVID or a TB or non-TB. That is called classification. Whether is there any fraud happens or financial fraud happened or not. Detecting the fraud actually is also a classification. So we discuss the classification. We discuss the regression. Regression is a prediction and getting that actually. So these two we discuss. Other than this, actually, there is some other things. There is something like a clustering. What is meant by clustering? So, for example, if you go give a information about the customers, like, so for example, if you are a shop and different people are coming, and you wanted to identify that, like, what kind of customers are coming to my shops. So you don't know that, like, you don't know what different types of the people. So, but how should we figure out? Actually, we are asking the machine, you only figure out actually what kind of different kind of personalities people are coming. So there is different ways actually. If, for example, if I'm trying to identify class of a people based on the how much they are shopping. So if they are shopping from 0 to 500 rupees per time, and that is one low kind of thing, and 500 to 2000 one class. So I can do based on the price. I can also do based on the frequency. So 1 week, how many times one person is coming. So highly visiting person, or like rarely visit or something. So I can do based on the visit. I can based on the pricing. I can do based on the their whenever they come, how much what kind of products are buying, the branded products, or like a price sensitive kind of a person. So he always purchase like which is a cheap. So it's like you can do multiple kind of segmentation of the customers. There is no fixed rules. So instead of me saying that, like, you do this actually, I'm trying to give the machine and saying that, like, so this is my information about the people who are visiting my retail shops, and this is their transaction, and this is all those things. You figure out and say that, like, what kind of peoples are there, which is the best way of classifying these people based whatever the way you wanted to classify. Why I should be doing that? Because I need to know that, like, whom should I incentive. So for example, shall I incentive the person who is purchasing more, or shall I incentive the person who is visiting more, or shall I incentive the person who is brand conscious, not conscious concerns? That is the one thing. Or else, like, which kind of customers are coming more to me? Actually, are more people with price sensitive, then I will be changing my whole shop such that, like, my most of the products are price sensitive kind of thing. If the shops are more people with the brand conscious people are visiting the shops, then I will be changing my shop so that, like, I will be bringing more products with a lot of different brands. So why we need this kind of things are called clustering kind of application. So you can do customer segmentation. And there is one more called reinforced learning. What is meant by reinforced learning? So we understood the clustering, we understood what is called regression, we understood something like so now what is the other thing? Reinforced learning. So for example, if you wanted to say, see, if you say that, like, this is the number 2, so you are trying to train. I don't have a lot of data to train the model, but I know that, like, actually what is the right way or wrong way. So for example, if it is a 2, so if it is identifying it is a prime, okay, no, you have done good. So I am trying to reward him. So I will be rewarding that guy. Oh, you have done good work. And if it is 2, and if you says it is a non-prime, then I'll be saying that, like, no, you have not learned right way. I'll be penalizing. So the way we do our kids, correct? So if the kid does good habits, we'll appreciate and say that, like, you have done good. And if kid does the wrong thing, then you will punish it so that, like, it should not repeat. So something similar to that, if you are trying to mimic, so then that kind of concept is called reinforced learning. So what I'm saying is, actually, I'm reinforcing you, whether you are learning right or not right. I'm reinforcing with the awards or penalties. So that kind of models, like, so that kind of model is called reinforced learning, because we do that, correct? So if you are doing very good in academics, they will be giving rewards and awards and say that, like, okay, keep up your good work and continue something that, like, if you are not doing that, then you will be penalizing with the penalty and all those things, asking your parents to come and visit. So it's like, so this is we do in our personal life. So something that, like, similar to that, if machine is trying to mimic, that concept is called reinforced learning. So machine also does that actually. Anybody has any question about the reinforced learning? Okay. So these are the not only the things actually. So a lot of things are regression, classification, clustering, and we also have something like a two more type is called something like a anomaly detection. So what is meant by anomaly detection? So for example, if you know that, like, see, in the electrical word only, if you say that, like, every day from this area, so some segment of a area, this much electrical consumption will be there. So means, like, on an average from last 1 year, So something like certain kilowatts will be consumed. All of a sudden, certain peak happened. So means like during the Ganesh festival or like some festivals, people start stealing the electricity, and suddenly peak of consumption happens. So we know that actually on an average, this is the consumption, but suddenly there is a spike. So means like something is happening there, anomaly detection. So those kind of things, like, so normal pattern and there is a deviation. So if machine is trying to identify the normal pattern and there is a deviation and it's able to say that like I found some deviations, then that kind of models are called anomaly detection models. So we will be using that data, anything actually, like, so normal behavior, abnormal behavior. So anomaly detections we do, correct. So we know that actually, okay, so suddenly like if this guy is, see, because of the COVID everything, exams becomes online, and we know that person like in the first year or second year his average score was around 60%, but because of the online things, that person is started scoring 100 out of 100. So means like your anomaly detection models will trigger, say that okay, no, something is wrong, because I never seen that like first year is he was getting on an average 60%, second year also on an average 16%, but in third year, because of the COVID, when exams become online, but every time he is getting 100%, maybe something is wrong. So that is kind of things actually. Deviations, if you are trying to find out, those kind of models called anomaly detection. You can use anywhere. So it is why I'm trying to tell about this model. If you understand the models, what models does actually machine learning models does, then we can figure out actually how we can apply for the electrical engineering applications. It may not be, see, they are agnostic with applications. It can be applied in education, it can be in healthcare. So only thing is actually what you are trying to figure out. So where exactly in electrical things, anomaly, I said, no, the electrical thief detection is anomaly, correct? So normal consumption and suddenly there is a spike in the something, or like, so certain things are happened actually. So those kind of things. The another thing is actually time series models. What is meant by time series models? So you know that like number series, correct? So you already know those number series maybe in aptitude. So there is a 2, then there is a 3, then there is a gap, then 6. So means like I asking to find out the filling in the gaps, or like what is the next element. What is it? Means like what is that, like this is called series. So now series and figuring out the number. So this is series, and time series actually it is based on the time. So for example, same, it is a series only, but based on the time. So what is that actually? So for example, if you have metro in that Chennai or in Bangalore, so 2014, so metro riders are like 6 lakhs in per day. So 2015, if it becomes 7.5 lakhs, and 17 this much, 18 this much, 2021 this much, 2022 this much, and then you wanted to figure out actually what would be in 2022 or 2023. So what is that actually? It is the time. So over the time you are trying to figure out the series based on the time. So because of based on the time you are trying to figure out what would be the next value. That those kind of models are called time series models. They based on the time and based on the seasonality and all those things, variations based on the time. So those kind of models are called time series. We do that actually. So what are the some of the examples for a time series? So for example, if you are trying to do solar energy prediction, what is a solar energy prediction? So if you are saying that like you have put a solar plant in certain location, and you are trying to find out actually, okay, in 2015 it has generated this much electricity, kilowatts of electricity or megawatts of the electricity, and 2016 it has generated certain megawatts kind of thing, 17, 18, 19, and now I wanted to find out what would be the 10, 20 or something like so. So whatever it may be, so time series, maybe it may be decreasing or it may be increasing, there may be certain kind of pattern. Usually it will be decreasing pattern, maybe slightly decreasing per, up to 10 years, because solar panel has a capacity up to 10 years, the generation doesn't decay that fast, but after the 10 years then there will be a lot of decrease. So I am building these kind of models, like how much energy we can generate over a year of time, and building using the machine learning models. Those kind of models are time series models actually. So this is one kind of application. Any question about time series? So this is a one example what I have done for one of my client actually. This is South African company. So what their intention was actually, so based on the person consumption, like for example, they have a smart meters in so many households, and they wanted to check actually how the people's consumption. So means like how much units they are consuming and what would be the projection for them. So for next 1 month or next 2 months or something, and one is month wise, another was week wise, another was day wise, when he will be consuming peak electricity in the daytime or afternoon time or evening time. So building those kind of models, what is the useful for those kind of models? He sees actually what is the peak load. So what is the peak load, at what time the peak load, like for example, certain areas are residential areas, certain is a commercial area. So he wanted to check actually how should he balance his load so that it matches the peak load projected. And also like he wanted to see that like 1 year 2 year kind of consumption, whether it is growing or not. If he's trying to, it is growing further, whether he has to purchase the electricity from something else to sell to these people, because they need actually. Instead of that, what happens earlier without machine learning, it was completely happens order. So demand comes and then I will try to do that actually. But now you are projecting next 1 year what happens, next 2 years what happens, which time zone, means like morning or something, or which season is you need more electricity, and all those things you are trying to build a machine learning model. And based on that you are trying to optimize your supply and distribution. So this is the demand will come from these areas, X area, Y area, and this is time. And I am trying to optimize my supply and distribution such a way that like there is an uninterrupted supply for the electricity for throughout a year. So these kind of things possible because of the machine learning. So, and the models what we'll be using is what is called uh, time series kind of model, predictions model, forecasting. These models are called forecasting kind of the models. Anybody has any question about the forecasting of the model? So what we discussed actually, regression, classification, clustering, and some kind of a forecasting kind of the model, anomaly detection. So is only these kind of the models or something else also there? What is called association rules. So maybe you may be seeing some, if you are shopping lot of on online or offline, you may have seen something that like sale, discount, get one buy one free, or together bundled, and then say that like you can buy these things this price. So either the bundle product, either the discount product, whatever it may be. So you may be seeing lot in the e-commerce space. So what you will be seeing? So something like this you will be seeing. So milk, so you will be seeing something like this actually. Bread and egg plus means like usually somebody buying bread and egg also buys something like a milk. So now instead of selling individually, if I package them, and then what happens actually? So that some kind of a combination of the products, no? So they are not like randomly packaged, they are based on the association rules. Machine learning able to predict actually which kind of products can be packaged, which what is the buying patterns. Like for example, if you see here actually, how the customer, like customer one purchase certain kind of goods, like he purchased egg, he purchased milk, egg, sugar and bread, and what is the person to purchase, what is the person three purchase, what is the common among all these customers actually. So and figuring out that and trying to come up with a plan, either discount plan, either plan for clubbing this, bundling it, so that like I can sell either that is called cross selling actually. You can sell cross, or you can overselling. Overselling means like I'm enforcing that person, instead of he's taking 1 kg, 1 kg, 1 kg, by creating a package, I'm forcing him to take 4 kgs of certain things. Or like I'm forcing to buy something which he doesn't want also, because of proper packaging. So how should I know that like what kind of products I should package? That is based on the machine learning. So how it does actually, it calculates actually like, so these are the item sets and these are the data. This is the customer one purchasing, customer two, customer three, and what is the highest number of frequency of products which are commonly purchased by the things. And then I'm trying to see, and then can I wanted to add more, or can I add more quantity? So for example, if I find out this is the transaction is higher, more frequently purchased, and then I will try to figure out actually how the way I should be packaging. Maybe I will enforce him buying, instead of 1 kg keeping 1.5 kg or 2 kg, so that like this guy will be buy. Because what happens actually, instead of going 4 different location and buying something, if all those things are there in one place, so I will buy it actually. So they wanted to play around with the human psychology. How they will come to know about what kind of but like packaging or bundling data based on the association rules. This kind of model is called association rules. Anybody has any question about association rule? Okay. So what is the other thing? So if, for example, in electrical thing, if I have to do association thing, so you can do a lot. So for example, somebody is buying certain kind of electrical thing, and you can also ask you to buy some certain additional things. Association is actually bundling things, like maybe bundling battery with electricity consumption or generator or whatever, some kind of, it's like you wanted to do some kind of bundling. So we'll discuss actually applications little bit further. Any question here so far? So association rule. And the next thing is actually something called a recommendation engine. What is a recommendation engine? So we always do know. So usually, like if you go to a shop, and then based on your what is called look kind, or like he will gauge actually whether this guy is middle class or upper middle class, or like what he is looking for. And based on his previous, like maybe this person is similar to another person, and that person prior interest was buying high-end silk sarees or something like that. So what he will be trying to do actually, like see, this X person and there is a Y person. So if I'm this Y person is going to buy something, and he says actually this Y person behavior or like characteristics are something similar to the X person, and what happened actually, this person also looked, so it's like liked. So how it will be? So these two books are read by the same guy. So these two guys, they saw the same kind of sari or the ornaments or something, and they liked it actually. It's like they have some kind of a similarity on the things they look or like it actually. So for example, in this case, both are enjoyed the reading the same kind of books actually. Now what happens actually? Now this girl has purchased a new book, so I can recommend this person the new book. Why I should be doing that? So if I'm not doing that actually, then he will take lot of time to figure out what to buy. So he will be spending a lot of time. Like what is the intention of the company or like a shops is actually, if that person comes in the shop, as much fast as he can purchase and go out, because the size is limited, correct? So the shop size is limited. If everybody comes there and from morning 8 o'clock, and then they sit 6 o'clock, and then they are not able to figure out, and they are going, it is overcrowded but not generating any revenue. So such kind of things, like what they will be doing, they will be using recommendations. You maybe saw about in LinkedIn, this job may be suitable for you, or you maybe saw about in Amazon, somebody purchased this laptop, also purchased this bag or something else. These are all called recommendation kind of engines. That is one kind of recommendation. The second kind of recommendation is actually based on the item to item, like X item is same to Y item. So then based on the X and Y item, both are similar, I'm trying to recommend. So first one is actually based on the person interest. So user to user kind of thing. Second one is item to item. It's like if a person is liking, so for example, you are a person, if you are read one book actually, which is about business and entrepreneurship or something, and you purchased that last time, and then next time if you are coming, then you may be like last 2-3 transactions what you have done in the bookshop is about business and entrepreneurship. So next when you come in, actually instead of showing you fiction, novel, comedy and all those things, like he'll okay straight away know that, okay sir, this is another book which is very good, hot selling book in entrepreneurship or business something, can you buy, there is some discount. So possibilities of his buying that will be more, this kind of models. So figuring out these models actually what he will be liking. So if you are using machine learning, so that's called recommendation engines. So we will be using this recommendation engine a lot of times. Like what happens, like one of the prominent example for using recommendation engine is actually Netflix. So Netflix used to recommend which movie you will be watching next based on your past histories actually. So because of that, what happens actually, most of the time whatever is recommended is performing better recommendation. So because more and more people are using those recommendations. The same thing is actually Kia retail shop. So they are also using recommendations engine actually. This is a different kind of series, anomaly in detail about the models, and then I will discuss actually how should we apply these kind of things in electrical engineering. Because if you don't understand what machine learning does actually, then you won't able to apply those things in an electrical world. So that is the reason I am spending more time on explaining the models. So then the next question comes actually, what is the difference between the machine learning and deep learning? So I already told actually this about machine learning and deep learning. Then what is the deep learning? So this is also learning, machine also learning, deep learning. So much like this is everything is same. Here also the machine learns actually, but the only difference between the deep learning and machine learning is, so in the machine learning, I am trying to give the features. So what is the means by the features? Like, so I told now housing price prediction. What are the features of the housing price? House price features, the square feet area, location, type of the house, what is when it is constructed. These are all the features of the house. So which we'll be using, creating a data about these features and feeding to the machine learning model, correct? So then machine trying to predict the price. So in that case, I am who will be doing this feature extraction, or like which features represent that information. For example, if I have to say that like the house, so if you say that like can you tell me the feature of a house, so if you say that like how is my house, so you'll say that like this house is built in 2014, I have a flat and in this community, and from my house this kilometer, means like this is the characteristics of the house actually. So which are important characteristics one will look into while buying the house, so those are called the features. Like, so because suddenly I some features are not useful for me to decide the price, or whether I should be buying or whether I should be renting. So which features are very important about that house, which will be people will be looking to whether to rent or house. So those prominent kind of features which explains describes the house are called features. And those features who will be extracting, we will be extracting, because we know we have a domain knowledge. If I'm a real estate agent, or like I'm a sales like salesperson, marketing, builders kind of things, I know that the what all the important features of the house and what people look for, and based on my experience I'm extracting that feature. Because why I should do that? Because machine doesn't understand. If you give the right data, then machine understands right way. If you are giving wrong data, machine doesn't understand right. Because if I'm giving random kind of a data, because machine trying to figure out based on the random data, maybe the success of like prediction model maybe go right or wrong. But if you give the right data and right kind of relationship data, which is very important to describe that object, so then model will be very good. So in machine learning, feature extraction is done by us. So feature extraction and the data set we created and will be giving to the model. In the deep learning, we won't be able to do the feature extraction. We are saying that like, I'm just giving the image of the house. So I'm asking you to figure out actually. So in the case of this example, instead of me figuring out the feature, what is the type of the model of the car, wheel size, engine capacity, diesel engine, petrol engine, all those things, I'm extracting feature and feeding to the machine model. I'm saying that like take this feature picture and say that like this is something picture, car thing, and this is the price of the car. This is another picture, and this is the price of the thing. And you only figure out, you only extract the features, you only do everything. Because first of all, I have uploaded my model logic building to the machine. No, I am offloading other thing also. First I have uploaded, I am not writing the logic, so you figure out logic. So that is done by the machine. No, I am uploading feature extraction also. No, I don't take this responsibility. I'm giving the data image or something, you only extract the feature which is important, you only figure out, you only build the model. And I just wanted actually take this image, and so next time if I give some image, then you should be able to. So for example, if I give a car image, you should say this is a car. If I give something like a camel image, you say that like this is camel. If I give something that like a baby image, so it's like human beings. It's like I'm not taking what is the feature important for these things, like you only figure out. So it's like I'm uploading feature extraction to the machine itself. So deep learning and machine learning is this the difference. So anybody has any question? What is the difference between machine learning and deep learning? This is a key important difference. Other than that, actually, like why people are running behind the deep learning, because so now if you have a domain knowledge, if you have understanding about the domain very well, then you can do the feature extraction. But if you don't have a domain knowledge, then you can't do the right feature extraction. So instead of that, if I ask the deep learning model to extract feature, the deep learning model gives better performance than me. So that is the one reason of people moving towards the deep learning. And another thing is actually nowadays we have more and more data. So more and more data are there. And what is happened actually in machine learning model, even if after extracting feature, if you give increase the data size, so learning doesn't improve beyond that time. If you see this curve actually, so amount of data means like amount of data you are feeding to the machine, even if it is increasing, it the learning will improve for certain extent. After that, like it will go flat. But in deep learning, So it keep increasing. So that is the other reason. If you have more data about anything, then you will be opting the deep learning, that because that will give you the better result compared to the machine learning. So these are some of the what is called key points you should be looking about, whether I should be using machine learning or whether I should be using deep learning. So other than that, a lot of other things are there. I'm not going in detail because already we are at 5 o'clock. So I have another 30 minutes to cover things. So far we understood what is meant by machine learning, what is the deep learning, the difference between machine learning and deep learning. Then if I have to build a model, what are the key aspects we should be knowing? So what are the key aspects? Already by this time you should have figured out actually. One is the domain expertise. Why we need domain expertise? If you are using machine learning, you should be extracting the features, so you should need the domain expertise. So if you have good domain expertise, you extract the better features, and then you will be feeding, learning will be far better. So or else, like, even if you are doing a deep learning, you should know that like which feature, like, so for example, if I'm trying to figure out the COVID or not COVID, so you should be figuring out like different kind of images, so that like which whatever the data you are giving model to the model, if the data is unbiased, it is well represented, and then it will, you will get a good result. So one is the domain expertise, because that which data is very useful, so will be based on your domain knowledge. So one is the domain expertise, and second is, another thing is actually, other than the domain expert, where exactly you can apply. So you cannot see, if you don't know the deeper about the domain, you don't know that like where should I apply the machine learning or deep learning. Because if you are electrical engineering, so you know electrical engineering very well, so then your knowledge about electrical is very good, and then you know that like where exactly I can apply the machine learning and deep learning. If you know other side, actually one is domain knowledge, another side is actually the machine learning, the concepts and tools and model building model for machine learning. If you have the concepts of like what all the math or statistics or like the tools to use to build a model, and the different algorithm models actually machine learning, you know, the like the types what we discussed, anomaly detection, time series. So if you know this side, and if you know the domain knowledge, you know that like where exactly I can apply the machine learning to solve, or deep learning to solve the right problem. And the third pillar is actually data. So if you have more data, relevant data, right data, then model will be learned, because machine is learning based on the data. If you are say something that like you say that like why your parents will be scolding you, you join with the right kind of mindset people, don't join with the wrong mindset people, because if you join the wrong mindset people, you will be learning wrong things. Something similar to that, because here machine is learning from the data. If the data is right, machine models will learn better. If the data is not right, if it is skewed towards certain kind of skewed ideas, then model will be skewed actually. So data also is very important, and domain is also very important. Then the last thing is actually, since this is a little bit like a higher side, may not be necessary, but somebody wants to do research in that, actually the continuous learning, the things keep on changing. So like COVID-1, COVID-2, Omicron came, and some characteristics keep on changing, evolving, correct? So you should be you should have a mechanism to feed the changes in the data sets or like environment to the model, so that like it relearn. So earlier you have thought something, and then maybe something else you figured out actually, because before COVID some pattern, after COVID some pattern, or like maybe you introduced some new concepts which was not known earlier. So it's like model should be keep on learning, continuous learning, new data, and keeping. How should we build the model such that like it get the new data and get trained, so then it keep on updating. So you maybe saw about Google search engine, no? So you will try to type something, and it will tell what is the next word. So what is that actually? Not only it is suggesting, it is also getting your feedback. If you say selected that, then it understands actually, okay, you selected that, means like my prediction is right. If you, instead of that, if you type something else, then it will say that, okay, maybe other ways also, other way of suggestion also will be this one. So means like it will feed this information to the model, so that like model will train further, and next time when you are trying to do, so it efficiency will increase. So that kind of model of continuous learning. So we should be building such kind of models which is continuously learning. You should build that kind of mechanism framework, so that like it learns continuously, the way Google does actually. So, and explainability is actually like, for example, whenever you go to the hospital, what doctor does actually, he says actually you are a COVID, and X-ray machine, he will say figure out actually which area something is there. Based on that, I am trying to figure out which is because of that you have a COVID. So That is called explainability, because instead of just saying that like I saw X-ray and you have a COVID, so the patient will be confused. Sir, why you saying that like you're COVID? So because nobody likes the black box. So machine learning is black box. So if you give the input and it says actually image, they say this person is COVID. Doctor confused, no? So why you said it is this person has a COVID? So you need to somewhere, the way the doctor explains the patient, you should have somewhere some mechanism to explain the person that like because of these things X Y Z, or this reason or this area, this feature, or this like your BP is above this, or like sugar level is this, or some because of certain things I have figured out actually you have the COVID. So that kind of models, like apart from the model prediction or like classification, you should also have explainability in the model. So those kind of model are explainable kind of AI. And recent trend is actually in the fourth pillar. Like most of the people are doing research in the fourth pillar, where adding the continuous learning and adding the explainability. These are the four pillars of the models. So far I have covered a little bit like basics about the what is the machine learning, deep learning, and key pillars. So now we'll discuss actually how should we apply into the electrical engineering. So for example, anomaly detection. We know what is meant by anomaly detection. Where exactly we can apply anomaly detection kind of concepts. So fault detection in the transmission line. So for example, if you have a transmission line and everything is fine, and all of a sudden something got failure in transmission line, how should we figure out? So you know that like maybe connectivity or like electricity for the smart meters, like so houses beyond that transmission line, maybe something like that. Like maybe what happens actually, still certain kind of grids or like poles, things are right, everything is on plan, but all of a sudden something had happened. Maybe so consumption was something similar, but all of a sudden consumption dropped or like peaked. So those kind of things called anomaly detections. Like what time it happened. So normal consumption, it's like you will see that like actually where exactly there is a failure is it. Those kind of models, like you can say power trips or hazardous things. What kind of model will be doing to find out power trips or hazardous kind of things scenarios? So you'll be using anomaly models actually. And if you wanted to, if you see that actually somebody power theft or not, you will be saying like for this locality, this much consumption will be there, suddenly increased. Maybe we should be predicting. How you will be predicting? Your prediction model says actually year on year, month on month, day on dawn, this is the consumption from that area. So suddenly there is a spike happens, then it will alarm you that like something is happening, maybe theft happening, something is happening, anomaly. So you should go in that location and figure out. These kind of models can be built. So smart decisioning. So maybe earlier, like we have a smart home and smart applications. Like what used to do, we used to program. So used to program saying that like 8 o'clock you switch on the light, or 9 o'clock you switch off the light, or something like that. So that is like logical rules we used to write and then control the homes, smart homes. But now what happens actually, because of the machine learning, so it is trying to take a lot of information. For example, take example of a AC. So is AC automatic control, how it will become, how many people entered in the room and what is the current temperature, and then it is trying to figure out actually and something. But later on, if the house is of different location, is humidity is more, or that because it doesn't take consideration other than the whatever the program. But if you add a machine learning and continuous thing, so it will take a lot of combination and automatically adjusting. So if more people are coming and if like, so if you machine learning or deep learning is something that like smartness you are adding to the device. So device started thinking the way human beings start thinking and automatically controlling the AC temperature happens. So any device you can add the machine learning, deep learning, makes much more smarter. So any device, like you can be used in number of devices. So and another thing is actually battery management. What exactly battery management? Usually used to say that like how many days battery life lost, how is the battery decay, and how much charge, how much time it will take to charge. Lot of things. Now in EV, lot of automotive vehicles, like so many people are using machine learning to find out battery life. So figuring out actually how much. So battery life is actually prediction or time series, you can say. So time series kind of models. And how much time it will take the charging. So depending on, see, it is not always like what is the current charge level and what is the expected charge level, it will calculate what is the time. Not only this, actually this is your logic, but what is the current condition of the battery, identifying the condition and automatically calculating. It is not like a constant kind of, like we are not defining the rules time. So we are just feeding condition of the battery, how, what is the current condition of the battery in charge, and automatically it will figuring out. So what we'll be doing, we'll be doing those kind of experiments and creating the data. So okay, this kind of state of the battery, and this is a charge and this much time. So I will be trying to create a data set for that. Actually, how I will be doing, so for example, this is the battery state and current battery current charge, battery current charge actually, and then how much time it will take. So I'm trying to create this data set. So I'm trying to, and any other parameter, a battery model. So if you are trying to do, and how many years, how many times it was charged, battery previous charging time, number of times actually charged, number of times it is charged, and then time it will be. It's like if you create this data set and say that like, okay, so this is different stages of the battery, and you are charging, practically you are charging and measuring the time and feeding the model, machine learning model, and later on if you give those different stages of the battery, automatically it will say how much time it will take. So it's like machine is started learning from the data. So these kind of models like battery life, most of the EV vehicles, like now EV vehicles, everybody is introducing this battery management. Like almost so many startups are there in this space. They are calculating battery time, charging time, battery health prediction, how the battery decay. So it's like how the battery charging capacity will decay. So this is also based on the machine learning models. So based on that machine learning, it will say that like how long it will last. So all these things are based on machine learning. So instead of using the traditional method, machine learning gives a better accuracy. So you can apply there. And what are those models? Like when you say how long it will take is the what is called is the time series kind of models. Or like if you are saying that like how long it will take is a prediction kind of models. So you should be able to figure out actually what is the objective you are trying to solve. And it may fit into anomaly, it may fit into prediction, it may fit into what is called time series, it may fit in. In fact, you should be able to figure out like what I'm trying to do, and then you should be able to figure out how should I know that. If you have a domain knowledge, then you will be able to figure out like what is the important for decay. So decay means like how many times you have charged, how many means like what is the current peak current capacity and how it is. In fact, you need to know those features, and then you should be able to figure out what model I should be building, and then it does the thing. So you should be figuring out. Other than that, actually, power purchase optimization for the end user, or power purchase optimization for the supplier. So for example, if you look for the power purchase optimization for the end user, so now if I know that like, okay, if I am the end user, how should I decide actually whether I should buy the electrical power, solar power, or hydro power, or wind power, or something. So if I know that like how the power price will be there in future, and then if I know that like what is my consumption thing, and then I can decide actually whether I have to switch or not. So or like which is the best way, best utilization. So then you can do, or you can recommend actually. So you can recommend based on if you are a price sensitive, this person is price sensitive, or this person is uninterrupted electricity. Then so because solar maybe fluctuation or maybe something like, so if you are looking for an uninterrupted kind of supply, then you opt for this, or you can opt for the combination. So these kind of models are there. Like a user will, instead of saying that like you just consume, we can also give the customized experience about power purchase. It's like based on like you say that like this is my cost and this is my thing and this is my requirement, like uninterrupted, or like I need power this time or this time, high this time low, and based on that like availability of my power, then I will say that like if you buy this kind of combination, it will be more ideal for you to and your cost wise optimized actually. So these kind of models can be built. So many startups are there in this space actually who are doing power optimization purchase, and for the suppliers actually, like how much demand will be there, which area demand will be there, and so then where exactly what is the transmission delay. Like for example, if windmill is far off actually, and transmission, how much is the loss, transmission loss, we can predict, and whether it is better to take supply from the windmill which is near to this, or like how to optimize my purchase and distribution. If I do say, for example, if I have to supply, I get a peak demand from Bangalore, and I have to buy power purchase from something like a North India, and transmission loss is more, then it will be more costly for me. So, or like if I do something like a route map planning, correct? No. So if you wanted to go from A to B, which route you should be doing? So something that like a power distribution and supply optimization is can also be done using machine learning. So these are the things they are using. So that is a part of a smart grid kind of concept. So you know already know the what is in the smart grids. So prediction models, energy theft detections. These are kind of the models are there. So what is the important thing when what you should be looking into is actually what is the essential area you're looking for, whether you're looking for the forecasting things like so energy forecasting, how much energy we can generate, or you can what is that actually. Another case is actually DC motors, like so if DC motors, if you wanted to get this much speed or this much what is called is actually uh, uh, maybe acceleration or a decreasation, what should I do? So instead of manually writing the equation, so and calculating, you see wherever there's a equation you will be writing a logic, no? So from this speed to this torque, if you wanted to go, then this much you should be accelerating or something. So that is your logic. So instead of wasting and writing your logic, because your logic is fixed, so it doesn't take a lot of conditions. So instead of that, if you are using, so what is the because you don't know the what is the friction if you are like a motor for the vehicle, then you don't know what is the friction he is facing, whether he is driving in the what is called desert, or whether you're driving in the mountain, whether you're driving into, because everything is dependent, no? So you cannot say that actually like everywhere it will be constant this much pedal or accelerator if you give, then you will get this torque, because you also need to, it's like, so those kind of like, so if you wanted to add the smartness into those things, calculations, you use the machine learning. Wherever there is a calculations are there, you replace with the machine learning. If you know that, like instead of you figuring out and writing the logic, because it is impossible to scale that actually. If further features are added, I said no in housing price prediction. If more and more features cannot be added, because you have to, it become very tedious to write and those kind of equations or calculations. That is the reason like driverless car was impossible earlier. So why driverless car is impossible now? Because we are not hitting those logic, no? When to stop, how to accelerate. It's like, so because live driving is like completely like only human, correct? So and earlier like we cannot predict right logic for that. So instead of that, like we use the deep learning, which can get the data and improves the learning. So that is the reason the some kind of a complex problems which were not able to solve earlier will be solved using the deep learning and machine learning. So any question here? And another one example is wear tear. So if you are using DC motor or like some motors or something, or like power transmitter or generator, you can predict actually machine failure. So what is the wear and tear and how long it will last? Because so earlier, like without this machine learning, so we electrician person will be going around when something is gone wrong happened and then trying to serve. So what happens actually, since because of that behavior, so 4 hours or 8 hours, maybe 16 hours, there is a power supply won't be there. So now you can figure out actually machine learning sees actually you have so many IoTs or sensors feeding the data about all these transmission IoT devices and everything. Based on that, you can see that like what is the power of failure. So failure or wear at year, and it will say that oh, this is a time for you should repair or maintain that, because or else it is going to fail. So these kind of models are possible, and because of that, like the devices like becoming more and more smart, and uninterrupted power supply is possible. So any questions here? So these are some of the examples. So I'm just giving highlight because I cannot be going on because within the 90 minutes I should be able to cover things. Like if you want, anybody wanted to discuss about any one area and say that like how can I apply, I can. You are welcome to discuss with me offline. So I will explain exactly which area, which algorithm you should be using to make it more smart device actually. So fine. So just to summarize, so what I was thinking, if you are enthusiastic about applying deep learning or machine learning in electrical things, so this is my based on my experience. So step by step, how should we do actually? First, you should understand. So just I said, no, you should understand what is the machine learning and what is the deep learning, what machine learning does, what deep learning does actually. If you don't know the capability of them, then you can't apply. That is the first thing that I will explain. Then second thing is actually understand the gaps in EA space. Like, so what is the problem we are trying to solve? See, power theft is a problem, or like solar energy prediction is a problem, or like motor wear and tear is problem. So you should understand what is the problem, or like how you are trying to solve that actually, how you are trying to calculate, how you are trying to make the device run smoothly actually. So if you understand what kind of equation is there, or where exactly you are using equation, or where your own equations, where you are facing the problem or a complexity to make it more and more smooth behavior or optimizing things actually. If you understand that actually not fully optimized, where is a gap, so then you can figure out, like suppose like you got the capability of the machine learning, and you got where exactly the area where things are not fully optimized are necessary to be optimized, because there is hazard. Like, so I'm not able to figure out the power theft, I'm not able to figure out actually which area how much power is there, like whatever it may be. So my grid is not optimized, means like load balancing is not proper, or like, so you, what is the problem area you're looking for, and if you understand that, then you figure out actually. So then you divide that part. Like for example, battery thing, no? So smart battery management, what is that actually? So in battery management means a lot of things. So is the battery decay is the one thing, or how much time it will take a charging is another thing, or what a recommendation. If for example, if based on the person uses, say some person is using vehicle for long drive, or this actually based on the vision, which battery kind of battery is suitable for him, because of his how much time he is doing charging and charging. So which model recommendation engine? It's like if you subdivide the problem into sub problems, and then you say that like this sub problem can be used, recommendation engine used to solve that. This sub problem can be used machine, the time series to predict it. This sub problem I can use something else. So instead of like, because straight away, because sometimes what happens, like one problem one thing, but one problem maybe multiple sub problems, and one sub problems you can use different algorithm to solve. So that is also possible. So if you understand that, then you can do it actually. So I have given the thing. Then when you understood that, like, okay, I can apply the time series and we can apply the anomaly detection or something, the next things comes actually, okay, if I have to build that, what kind of data I should be, because machine learning is based on the data, correct? Or deep learning is based on data. So what should I, if for example, I'm trying to do battery decay, so then your domain knowledge will play into picture. Okay, battery, what is the key features? Okay, whether I should, if I have more data, then I will be using machine deep learning. If I have less data, I will be using machine learning. And okay, now what features are, because machine learning doesn't have a feature extraction, so I should be what is the key features for deciding battery decay. So it's like all those things actually. Then collecting those data, so it's like wherever you are applying that like equations, like what are the features or parameters are there. So then collect those data, and what is the input and what is the, I gave an example, no? So for example, if this battery model and battery current charge and all those things, like I'm trying to extract that feature and building this testing and giving the data 1, data 2, data 3 for different models, and I build those data set, and then I'm trying to train the model. So this is very important. If you are not able to if you are not good at identifying which features are very important, then you cannot use machine learning. And if you are not able to identify collect the right data, then model won't be good. So this fourth and fifth will be very good, very important. And that in that space, electrical engineer, a computer science, like if I'm a computer science engineer, I cannot beat you because I don't have that knowledge. So that is the advantage you people have. Electrical engineering guys with the machine learning will always preferred in electrical kind of company, because you have those domain knowledge and you have those skill sets. Because that it takes for me to take a lot of time to figure out actually what all the small areas or gaps where I can apply the machine learning, because I don't have those knowledge actually. Like, so since you are electrical engineering, you know those things actually. I may be just telling high level kind of features, but detailed features, you are the only one guy who knows actually which features are very important. So this fourth and fifth, if you are done very good, then your model building is a common thing. So you can build the model, and you can make the model explainable thing, and you can make continuous learning things. So this is a step you can apply. This is irrespective of electrical engineering. It can be applied for any engineering. For since it was about applying electrical engineering things, I'm just telling this is my way of applying machine learning, deep learning to any domain. So if anybody has any questions, let me know. I'm done. So still I have around 15 minutes actually. So that is for question answer. So if you have any question answer, let me know.
Yes, thank you very much, sir. That was quite an informative and engaging session. The floor is now open for questions for our guests to address one by one. So, Shreya from the chat box is asking, one of the major applications of machine learning in day-to-day life comes from home automation. The rise in smart devices has been exponential. What are your thoughts on the same?
Yeah, actually, like in the smart home area only, machine learning is applied very first actually. See, I will tell you which are the areas machine learning applied first is smart home, solar energy, battery, distributions. Like so, all this power consumption and distribution. These are the main area where machine learning and deep learning applied. And like you saw that like Alexa and all those things like AC, every devices. If you see all home appliances. Earlier, they used to say that like electrical appliances. Now they are saying smart devices. It recognizes your face. It understands your mode. What is that actually like? If you go to the in front of a TV, sees your mood, or then okay, this mood is sad. Then I can switch on some romantic or whatever it may be. It's like these kind of applications are coming up. So this is the area if you are looking for like a long run kind of career. So this is the one area. So and if you, but this is like where electrical and electronics guys can also be participate. But if you are very wanted to specifically, I wanted to be in the one area where no other person can compete with me, then you choose a little bit like a battery kind of things or like solar kind of things, because other guys like electrical electronics guys or like computer again cannot come there because you have a deeper knowledge. So it is up to you which choose. But like rightly said, so many consumer electronics companies are there. They are enabling data science and AI everywhere, every application. Can you give lean content recommendation model in machine learning to create OTT platform in the future? So lean content recommendation model. See, a recommendation model. See, all these Netflix, almost all these Netflix or like Amazon Prime or Hotstar. Everybody is using the recommendation engine. But in recommendation engine, there are multiple things are there. So one thing is actually user to user, item to item. But another thing is actually, so for example, if that person is not even logged in, so how do you know that like how is our person? So based on his first click, so that is session based recommendation engine. So usually there is a not only one way of doing. I said no. So first is actually session based. When he logged in, if you see actually, or like uh, another thing is actually based in not even based on session thing. So they were also taking actually which location you are there. So if you are logging in from Karnataka, Bangalore, they think that like this guy may be interested in Kannada movies or like some kind of things. So they have predefined what is the geographical information. So there are different kind of models can be built. So considering your geography, considering your session, considering an user to user, means like it is there is a flow of like how you are trying to build a recommendation engine. So maybe if there is no data is there about that person, then you take the geographical thing and then the session based thing. First you have to take geography, because even not started logging in, clicking something, correct? First geography, then transition to session based, then transition to user, then we figure out this person is of what type and then recommending that. So there is a sequence of things you should be doing to make a better recommendation engine. So if you just stick to user, then first time logger doesn't have any value. So it's like he will feel that like you are not recommending right thing to me. So that is how you should be solving it. So I hope I answers your question. What is
Yes,
the
yes, sir, that was a great answer. Raghav from the chat box wants to ask, how far does machine learning stretch in the direction of detection?
what is the last one?
Sorry, sir.
Which question?
Sir, So the question is, how far does machine learning stretch in the direction of detection?
Stretch means like how far it will be proper or accurate, you are saying, correct? Stretch means, so I didn't understood stretch means. So you are saying how far you can apply, or how good effective it is. That is, what is that question actually?
So he basically wants to ask how far you can apply it in the direction of detection.
Direction of a detection.
Yes, sir.
See, depends. Let's see. I said no. Machine learning and deep learning. Main thing is actually how much data you are there. So if you have right data, whatever you are trying to do. So if you have a right data for that information and more data, relevant data, proper data, you can apply. If you don't have a data, then it will be difficult. You don't give the result, and you should keep on building, and then you should be using something like a reinforced learning if there is less kind of data. So you need to figure out actually, and there is no such thing that like there is a limit for machine learning or like. So what happens actually, like after certain kind of number of data, there won't be any improvement. See, if you think actually first you will be collecting data and building a model, and after that, like if there is no improvement, then you need to figure out actually like I need to enhance the further data, or I need to optimize, or I need to move from maybe machine learning to deep learning, maybe if still possible reinforcement. Like you should have to switch around that actually to get a better result. So I hope I answers your question. Then what is the other? Deep
Yes,
learning
sir.
is deep learning. As we know, deep learning is used in machine medicine and pharmaceutical areas. Do you think that is good area to let very advanced software help cure disease, etc.? Yeah, so that is what is happening. No, most of this med kind of things like medicines, like uh, solutions are coming up. So since for basic kind of thing, because see what happens actually, even if you see the doctors, how the doctor learns, they will see one patient and then give the medicine and then see that like whether improved or not. They are learning. Then another medicine and then they see that like whether, because they also experiment on our body, correct? So now all this data, if over a period of time, doctor learns and then gives a better kind of things. So something similar to that, like if you keep on feeding the right data and machine started understanding, and machine can also cure actual disease. So for acute kind of diseases, machine learning, deep learning is used to recommend the medicines actually. But only the constraints is actually not about the model, but it is getting FDA approvals, getting the government approvals, all those things are there. But machine is capable, deep learning models are capable to do. And what is the observation is, if you see that like uh, except that expert or specialist kind of doctors, machine learning, if the doctor is not that expert or specialist, he has not seen so many patients, actually his learning is, machine learning can beat those kind of doctors actually. So it is possible if enough data is there. So what is the other question? We have worked on a project related to machine learning or deep learning. Please tell your experience. So I have done a lot of things. Now this is one example. So I have done. This is for one client actually. Power Star is a South African company. In this is about electrical domain, no? So predicting. So month wise power consumption prediction, user wise prediction, and whether the user after certain bill happens, whether the user churn prediction, whether this person will quit, switch to another. So all those things models we have built actually for this. And when is the peak time, which month is the peak time, all those things. Like so this is used by the company to balance his, like, and also like what is called maintenance. So when is the possible of maintenance, like based on how many users. So every time, like after certain kind of thing, they have to maintain that meter or like electric connection, no? Because it will go decay. So predicting when is the maintenance necessary. So those kind of models can be built if they give the proper kind of data. So that I have done actually. And I worked on that. So I have worked more. I have worked in analytics. I have worked in, because my company Pragyan AI is actually training people in data science and AI. And apart from that, like we also have our own products. So we also guide the research people. So we along collectively, if you look so many, like every week one or two models we keep on developing, either guiding the people or developing actually people. So we used to do actually, like there is no limit actually, like what we have done. So, sir, do you think if we have developed a deep learning properly, it would have been easier to find the cure of COVID-19? Yes. So, actually, later on, the models are developed. Earlier, it was not developed. Like some companies started picking up and they started figuring out actually, because what was the issue happened is actually like a specialist doctor to read X-ray image. Radiologists were not there, and remote areas which is not there. So, but what was the issue will be initially for AI model, we need a data. So you need to have a data and then the model, and because we can't predict something, correct? So the cases, because nobody knows actually what is in the COVID. So if nobody knows, then if they are not labeling the data, this X-ray image for COVID or not, then model cannot learn. So it took some time to collect the data. Some company startups have started actually. Because of that reason only it was cured very fast. No, because of that reason only vaccine is invented very fast. So think about all the pandemics, earlier pandemics in history. So they took 20 years, 30 years to die that disease. But if you see that like COVID-19, vaccine invented in less than 2 years, and COVID, like even the first wave, second wave, like so much is the fast. But possibilities are actually like nobody knows it, then we model cannot do that something. So, but it if without this, it would have been with drastic disaster actually. So, as per my experience, I'm not saying that, like, but as per my experience, because of that, things becomes controllable. So, what type of algorithms used in SOH and SOC in battery management? See, I said no, a lot of things I told to find out. Like, see, the one more research is happening. So, there are what kind of components, battery components will give better charging thing. So, instead of building that, and see what is, I will tell you the similarity between the COVID vaccine generation and this one. So, there is something like a generative kind of models. Generative kind of models means like it will generate data. So, something that like generating a different face or generating something things. So what is that actually, they will see what characteristics of these components and chemicals are in it. And if you use this kind of combination, it may give the better result in the battery. So what is they are trying to, without this machine learning, they used to, they test one model combination and they see that like thing, then they test another, then other. It's like everything they have to test. Now after testing like 8 to 10, and if you got the characteristics things about these components, and then how much the capacity of the battery or life something, and they can use this data to build a model. And then they have started generating multiple combinations and predicting what would be the possible outcome, and then selecting, recommending these may be the combinations you can use to get. So it reduces the innovation. So speeds, fastens the innovation. Same the way the vaccine generation innovation. No, so it starts. So same logic can be used. It can be used in drug discovery. It can be used in vaccine discovery. It can be used in battery thing. Which kind of combinations? And apart from that, like I already told, no decay and all those things. So you can use those kind of models in the battery management. So any other question?
No, that's about it, sir. Thank you, sir. That was quite a dynamic Q&A session. I'm sure that all the questions were answered to the participant satisfaction. I am sure the attendees learned a lot about the applications of machine learning and deep learning in the field of electrical engineering. Your research and knowledge in the subject is surely impressive and inspiring. I like the part where you explained to us the difference between machine learning and traditional programming and used examples and models from our daily lives so we could understand the topic better. I would also like to thank our esteemed speaker for this insightful session. Thank you again, sir.
Thank you, thank you. It was wonderful audience, because I see the enthusiasm for the people and asking so many questions, wide range of questions, and lasting till end of the session, because 4 to 5:30, I think the last day, and maybe people are interested to wind up the college and go out and enjoy. So, but it was very good audience, and you organized very well. And thanks for giving opportunity to speak to you all, and always like to engage with the young minds, because you are the future of India. And if you understand machine learning or deep learning very well, I hope that one day you will be building a lot of good products in electrical engineering. And thank you, appreciate your kind gesture. See you then.
Yes, sir. Thank you. With this, we come to the end of our second session for the day. I thank our audience for their patience and our speaker for taking out his time for the event. I would also like to request all the attendees to stay back for the third session of the day as we continue our deliberate discussion on tech crypto scope and opportunities in machine learning in the coming decade with Mr. Yadnesh Mohan. A feedback form is being sent in the chat box. Kindly make sure that you fill it. To avail the e-simulate certificate, the attendees need to attend at least 7 out of 10 sessions. Your feedback is very important to us as it helps us conduct many such events that are insightful and enlightening. This is your host, Gargi Thakur, signing off. Thank you.
Thank you. So I will sign off. Fine.
Yes, sir.
Okay. Thank you.
I'd like to repeat once again, a feedback form is being sent in the chat box. Kindly make sure that you fill it. Please stay back for the next session. We'll be beginning shortly.